Okay, and so last time we looked at the coordinate axes and we talked about having unit vectors I, j and k in the x, y and z direction, which enabled us to cover the space to have any direction we wanted as a combination of those things. And this time I just want to have a look at getting an appropriate length. So I want to be able to use my vectors I, j and k to get to any point at all somewhere in the space. So in this case we're going to try and head off to point A. So effectively it's a vector from the start in the direction of u, but the full vector has length A. So shown on the diagram here is the red vector. And what I want to be able to do is to get to that using the combinations of i's, j's and k's. So I need to start from the start and end up at the finish. So if I start from the start, I need to head a particular direction, a particular length in the I direction. So this new vector does that. So A1 is a scalar, which tells us the appropriate length to head in the I direction. So this vector is in the I direction of length A1. And then I want to head off in the J direction. So I have another vector which does this. So again, A2 is a scalar and it's going in the J direction. And then I need to get a vertical component as well because A is obviously above the XY plane. So I put another vector in here, which I'm going to call A3K again. A3 is a scalar and K is the unit vector, which gives the direction, in this case the vertical direction. So these three vectors, A1I, A2J and A3K, combine together to add up to give me the equivalent of the vector A. So notice I have A as a vector, which starts at the origin and ends up at point A, is equal to a combination of the unit vectors I, j and k, each with an appropriate scalar, A1, A2 and A3, to move in the right amount so that the total comes up to equal A. And usually we draw these with the vectors along the axis. So rather than having A2 sticking out here in the middle of the plane, we take it away from there and bung it along the y-axis in the j direction. And the same with A3, we wouldn't show it here, we'd show it up the vertical axis. So we have exactly the same three vectors as I had before, but they're shown along their axes now. And the vector equation, A equals A1I plus A2J plus A3K, still holds perfectly well, and we can notate any point in the space in terms of what's called a linear combination of the three unit vectors.